Okay, so let's summarize what we saw. So what did we learn regarding soft actor critique? We saw that first of all, we saw the maximum entropy objective. We saw that higher entropy for a policy results in more, some would say, better exploration. More exploration and better exploration provides us with higher chances of overcoming local optimum, and also, well, they allow us to not commit on a specific policy, so we're more flexible, adjusting to changes in the environment. It is worthwhile to encourage the policy to be of high entropy, even at the cost of lower expected return, right? So we say, increase entropy, even if you decrease the expected sum of rewards slightly, it's still beneficial to do that. Probably due to the added exploration and added robustness. Sampling a soft policy for an action results in high noisy gradient estimations. So in order to address this issue, we sample noise from a fixed distribution and provide it as input into a hard policy that is based on our soft policy, the one that defines the mean and standard deviation for our Gaussian, which is provided with the noise separately. This is the reparameterization trick, and we didn't see the results, but this helps a lot with stabilizing the learning. Without it, soft actor critique is not very stable, but with it, it's actually much better. What did we learn regarding the deep deterministic policy gradient? We saw that generalizing DQN to continuous action spaces is challenging, it's not straightforward. We can't enumerate overall possible actions, so we cannot compute the argmax over the actions. DDPG tells us, or trains, a deterministic policy that approximates the argmax over the action. The action argument max over the Q values for a specific state. And then we train the deterministic policy using gradient ascend with respect to the approximated Q output. Right? So we propagate the Q gradient through the Q network and all the way into the policy network in order to find the best the best action given the Q value. Okay, some extra readings. So these are just the links to the papers that we discussed. The soft actor critique, the DDPG, the summary of these algorithms on OpenAI's website, and this is the paper describing the reparameterization trick. What's next? So next we're going to discuss imitation learning, where we're trying to not necessarily optimize the sum of rewards. We don't have the sum of rewards. We might not have a reward function. We just have either an expert or demonstration from an expert acting in our environment, and we would like to imitate the examples, the demonstrations, or the demonstrator as closely as possible. It's related to RL, but it's not exactly RL. We'll see this in our next topic. With respect to the assignments, so you can now go ahead and implement your DDPG implementation. You still have A to C, reinforce, and deep Q learning, which hopefully you're towards finalizing these assignments. Quiz, you still have this. Oh, so now you'll have available on Canvas the soft actor critique quiz. And with respect to the project, please start finalizing your literature survey. Okay, thank you.